All right, thank you for tuning in with us today. My name is Philip Heedy, and with me is my colleague Whit Mateau. And together we're going to be talking about best practices for layers and service types in ArcGIS Enterprise specifically, but also touch a little bit on how some of this stuff relates to ArcGIS Online. We have quite the agenda for us today. We're going to be talking about some initial concepts and the technical foundation for everything that we'll be touching on later in the presentations. Then we'll get into the meat of the presentation with an overview of the various GIS services that are part of ArcGIS Enterprise. We'll talk both about the concepts and the individual service types. And then we'll get into how this relates to higher level objects and items within the ArcGIS Geo Information Model, things like web maps and the layers and how they relate to those services before ultimately rounding it out. This is a quickly evolving topic, so we do want to make sure that you're aware that this continues to evolve. We've done various versions of this presentation for a while now, and even just over the last couple of releases of ArcGIS Enterprise, some of this stuff has evolved and improved significantly in certain ways. So this particular presentation is current as of March 2020, and the ArcGIS Enterprise 10.8 release that just came out here just a few weeks ago. If you're watching this recording at a later date, check if there's an even newer version and see if there's something you should be looking at there. If you're working with an earlier release of ArcGIS Enterprise, that's okay. A lot of what we talk about, we will point out when things have changed and what new features became available with those different releases. And with that, I'll hand it over to Whit to talk about the introduction and concepts.
Great, thanks, Philip. Before we get into the technical details, of which there will be a lot in this session, we wanted to start with a little bit higher level concepts to explain what we mean when we talk about publishing, what do we mean by services and layers, and sort of why we think this is an important topic. So way back, thought it would be helpful to understand sort of how we think about the ArcGIS platform conceptually, and how that aligns with the technology that we all work with on a daily basis. So if we think at a really high level, conceptual level, ArcGIS is really about connecting users with data in a way that solves a specific problem or that helps them make a better decision. And the way that happens, we think of as falling into these four levels or these four tiers. At the lowest level, we have different ways of storing data. So that could be in something like a relational database. It could be shapefiles on a file system, or it could be imagery residing in an object storage. It could be observations residing in a NoSQL database. There's lots of different ways to store data, and there's different parts of the ArcGIS platform that allow you to store different types of data in a mechanism that's most suitable for that type of data. On top of stored data is functionality. This includes things like making a map or performing analysis or performing a geocode. It uses the data that's been stored appropriately to provide some geospatial functionality to a user. They can range from something as simple as just querying the data to something as complex as running an analytical model across distributed data. On top of the functionality, we have what we call an information model, which is really about turning that data and functionality into something that's accessible to users and reusable across different applications and experiences. And then on top of the information model is a user experience, which turns that information and presents it to a user in a way that makes sense for what that user is trying to do. And that could get into things like web versus mobile, field versus desktop, simple experience versus complex experience. So this is a high-level conceptual view of the ArcGIS platform. As we think about how that's delivered through Esri technology, this is where we have the different components of ArcGIS Enterprise. And you can think about these same things logically existing in ArcGIS Online as well. There's data stores, and I'm using that as a fairly generic term. Philip will in a moment explain what we mean by the ArcGIS data store specifically, but here we're talking about just different ways of storing data. That could be a geodatabase or it could be something else. The GIS servers, what we think of as ArcGIS server within ArcGIS Enterprise, is what's providing that functionality, and it's actually doing that through a RESTful set of web services. It's really the portal that manages that information model. And when we say information model, we're really talking about maps and layers that are managed and stitched together in portal and then exposed to users through applications, which is really the user experience tier of the platform. And so these things all work together. They serve different purposes, and they allow for both very tailored experiences for specific sets of user, as well as reusability at multiple tiers. And so just to give an example of that, we might have, for example, a storm dataset. This is a dataset tracking a storm, and it's updated perhaps on a daily or even hourly basis. We may have a storm service that provides visualization capabilities, so you can watch that storm move over time. And we might have analytical capabilities that predict where that storm will be tomorrow. Those services are brought together as layers in a storm map that's managed by Portal, and then exposed through a storm viewer application. Those information products, so that we may have one map and one layer, or we may have different sets of maps and layers that are then exposed through different user experiences or different applications to meet specific needs without having to duplicate the data or the services. So this idea of flexibility and reusability, I think, will become a little bit clearer as we get into the details. So just to give you guys a few things to think about as we go through this, because we're about to get into some pretty deep details. As you think about how best to publish data to your users, these are some of the things that you should be keeping in mind. Who are we reaching? Who is our audience? Are they advanced users that understand a lot of strong geospatial concepts, or are they new to GIS and are more used to using mapping functionality for things like finding my way to the nearest store? Are they working on the web? Are they working on a mobile device? Are they disconnected? What is their form factor? What are the capabilities that they need? So what functionality do we need to provide on top of the data to meet their need? And then a number of non-functional or more technical things, like how fast does it need to be? Because often there's some trade-offs when you have to go for really high performance. Is this an application that might be made available to the public and therefore needs to be able to scale very elastically to meet potentially viral demand? And then things like reliability, or what we sometimes call availability, and security are other technical considerations that can affect how you publish content. And so just to give you an example of how variable this can be and why it's important to really think through this, if you're building an application that's going to be a public-facing power outage application that's used by the public in the event of a disaster, that needs to be very simple and easy to use, but it needs to be very fast and highly scalable and reliable. That thing cannot go down because people are depending on that. But it's not providing a ton of advanced functionality, and it does leverage the web. Contrast that with a field collection application that perhaps a utility is using to update electrical poles out into the field. That is an internal-only application with a well-known set of users that may not have connectivity all the time and is working with fairly advanced geospatial data, in this case, electrical utility data. The way that we would publish these applications and the content and information model that supports it is very different. And I think as we go through this today, you'll get a sense for how you think about how to publish content to meet different examples like this. And just the high-level approach to keep in mind, and we'll revisit this at the end, is it's important to look at the business needs or the requirements of what you're publishing for. So we think about starting with the end, like what is this going to look like when the consumers use the application? and then start working from the bottom up. Look at what data you have, what's the best way to store it, what's the best way to publish that as services, et cetera, up the stack. Do your best to align the needs with the technology that's available. And as Philip said, this is a rapidly changing field. Every release, we add new capabilities that improve your options for publishing content. So be prepared to be agile and adjust over time. So with those sort of concepts, I think we can get into a little bit more technical detail.
All right, thank you, Whit. So, like Whit said at the beginning, we think of things falling into these 4 different tiers. Data at the bottom, the way that that data is stored, the storage, the functionality on top, the information model, and finally the user experience or the applications that end users actually make use of to accomplish whatever task they're going for. There's a lot of things that you can do at the data store level as well as the application level in terms of different options. In this presentation, however, we're specifically focusing on those 2 middle tiers. The service tier, those web services that we publish to make our data available for some type of functionality, whether it's mapping and visualization or analytics, as well as the information model that then sits on top of those web services. That's the main focus of today's presentation. We touched on this a little bit, but when we talk about publication clients, I also want to make clear that we have the right terminology and we all agree on the different words we're using. When we talk about a publication client within the ArcGIS ecosystem, we really have 2. There's ArcGIS Pro, which is the modern publishing client. Pro has been out for quite a number of years at this point. And one of the things that Pro brings with it is support for a lot of newer capabilities that didn't exist within ArcGIS before. One of those capabilities is things like vector tiles, a new, different way of publishing your data for very fast, rapid visualization, and we'll talk more about that here in a second. As well as some of the characteristics of those web services that you publish. We introduced a new feature called shared instances with ArcGIS Enterprise 10.7 last year. And it's important to understand that Pro is where a lot of that support comes from. Many of you are, of course, also still using ArcMap to publish services, and you can continue to do that both today and in the future. What you will, in some cases, be missing out on is some of that functionality. So as we go through the presentation, we'll make it clear when there are specific features that depend on Pro specifically. The other big thing that I want to mention is this concept of where your data is stored and managed. We have a concept within the ArcGIS Enterprise platform called hosted services. Hosted services are most commonly found as hosted feature layers. This is something that's been around for a while. And this is really where ArcGIS itself is managing your data. You didn't bring your own database or file system or some other storage to the system. It came with ArcGIS Enterprise itself. So we often also refer to this as ArcGIS managed data. Contrast that with the more traditional services, if you will, where you are managing the data yourself. We call it user managed data for that reason. The quintessential example of this is you bringing your own RDBMS, whether it's something like SQL Server or Oracle or PostgreSQL, and you connect it to the system and you publish your data from there as services that show up within ArcGIS. We call this user managed data. Now, how this manifests itself is the hosted services or that ArcGIS managed data. Today within ArcGIS Enterprise, we have a component called ArcGIS Data Store. And that's really what this component supports. That is essentially that database where the data that you upload to the system or you generate through actions within ArcGIS Enterprise gets stored and served out from. And of course, you have a lot of different data sources that you can use by reference by connecting them to the system. Some other key concepts that are important to understand is the distinction between things like features and map images, the distinction between having an actual feature that you can interact with in the client versus a static map image. We'll talk more about that here in a second. We'll talk about tiles, caching, very closely related. Pre-caching data can be an effective way of getting great performance, but as always, typically comes with certain types of trade-offs. And then various types of generalization. We can have very, very fine-grained data, very, very detailed data, and generalization is a way of using just the right amount of detail at a certain scale level in order to accomplish what you need. So let's take a look at those concepts in a little bit more detail. When we talk about map images, this is where a client is making a request to the server. It's specifying typically things like the extent, what's the extent of the map that I want you to draw, characteristics like the size of the screen, so the image size I want back, and the format. It's things like JPEGs or PNGs. That request goes to the server and gets processed, and the server simply responds with that map image that was requested. The client receives a static map image that doesn't have any information about the underlying features that was used to draw that map. And contrast that with having features. And this is where the client sends a request that is essentially a query that says, within a certain geometry, filter out these features, and then return these fields for those features, these attributes for those features. And the response that comes back from the server is not a JPEG or a PNG image. It is typically JSON, or as we will see here later on, it can also, in newer versions of ArcGIS Enterprise, be other different types of formats. But when that comes back to the client, what happens is that the client draws that itself client-side and knows where the individual points, vertices of lines and polygons are located so you can interact with them. So at the end of the day, that means that map images are rendered server-side and they're fairly small. Right? You get a PNG or a JPEG back that's at most on the order of tens of kilobytes. But the trade-off here is you have limited client experience and interactivity because the client doesn't actually know what's there. Features are rendered client-side, and the trade-off here is that you can have a very variable payload that gets sent back to the client. Sometimes it might be a few kilobytes, sometimes it might be hundreds of kilobytes or even megabytes. And that has a big impact on the perceived performance, both because it takes time to download all that data and because it takes time to draw large amounts of data like that. On the flip side, you get very rich interactivity and a great client-side experience. The next concept that I want to talk about is the concept of tiles. There's different types of tiles these days. There's what we call raster tiles, as well as vector tiles. Raster tiles have been around for a very long time. In the very earliest versions of online base maps, raster tiles was what you received back when you zoomed around the world and you saw these rectangular or polygon images coming back. That was really individual image tiles streaming back from the server to the client being drawn. Raster tiles are extremely fast to draw because all the client is receiving is a set of images. They're fast for the server to provide typically because they're often pre-cached. That means the upfront work was done to create those tiles ahead of time. The server doesn't have to do anything other than read some data off a disk or object storage and stream it directly back to the client. A newer type of tile is the vector tile format. Vector tile layers have now been around for several years within ArcGIS and really has a lot of benefits over raster tiles. And we'll talk more about that here in a second as well. One of the other benefits of using these tiles is that you can also download multiple tiles at the same time. You get the benefits of parallelization. Both the client can download multiple tiles at the same time, as well as the server generating or streaming these back. If we think about caching, what I just described was caching on the server side, and that's a very common way of utilizing caching to speed up the perceived performance of the system. I mentioned you can pre-create the cache, and this is by far the most common way of doing caching. You take an upfront cost of running a caching job. It may take hours, sometimes even days if you're generating a very large cache over a large area. But you can also do caching on demand. So the first time that a client comes around and makes a request for a certain area, you generate the data for that area and store it for future use. If somebody else comes around and requests the same thing, it's now ready there. So the first client may see slightly slower performance as the data is generated, but everybody else sees much faster performance afterwards. But there's also other types of caching. You also have browser caching, or caching in memory on the client itself. And this is something as a web application developer in particular to be aware of and to use to your advantage, and make sure that you cache things yourself on the client. Sometimes this will be done for you if you use APIs like the ArcGIS API for JavaScript. Other times, as an application developer, you may be able to explicitly choose to do some of these things on your own. And then finally, I wanted to talk about generalization. This is the idea that you may have very detailed data sets. The example here is a set of polygons where, depending on what it is you're trying to do, you may not need to use all of that detail every single time. If you imagine sending all this detail, these features down to the client, in the case of sending features, then sending the full detailed data set may actually be quite a lot of data. If you're drawing at a very, very low, small extent, then you may not even be able to see all those vertices. So it's really a waste to try to send them down to the client. There's different types of generalization. Point remove algorithms have been in ArcGIS for a long time. Quantization is something we'll take a look at here in just a second. It's a newer way of doing this kind of generalization that's built into ArcGIS Enterprise these days. And then we'll talk a bit more about how you can either pre-generalize features, essentially have multiple different copies of the same data set at different levels of generalization, versus generalizing on demand. And generalizing on demand is really a very powerful method that we'll talk more about, because it's simply built in and is very seamless to both you as the publisher of a service and as the consumer of a service inside of an application. At the end of the day, what generalization does for you is provide higher performance. You don't need to send as much data necessarily. It can be faster to actually send smaller amounts of data, even if you need to do some work on it. And regardless of who you are, higher performance is a good thing. So with that, I'll turn it back over to Whit to talk about the different types of GIS services that are within ArcGIS Enterprise.
Well, as many of you may know, there are a number of different types of services in ArcGIS Enterprise. Today, we're going to focus on 4 types specifically, really 3.5, I guess you could say. These are map services, which can be published as both what we sometimes call dynamic map services or tiled. We'll also look at vector tile services and feature services. I suspect for many of you, these are the bread and butter of what you do. A lot of applications that we see you using ArcGIS to power involve mapping and visualization, often in addition to things like analytics. But this is the way that you would publish your data to be consumed in a variety of applications for the purpose of mapping and visualization. Now, these are focused on 2D. There are a number of other types of services that can also be used for visualization. Those include image services, which allow you to manage raw source imagery, to optimize it and serve it on the fly in different ways. Scene services are a type of service optimized for 3D use and visualization. Stream services use underlying technology like WebSockets to actually push features, really real-time data from the server to the client, so more of a push than a pull mechanism. And then there's a number of other services such as geocoding, geometry, geoprocessing, as well as specialized services like Workflow Manager and Maritime, as well as new services such as Utility Network and Parcel Fabric that support different types of use through the ArcGIS platform. So when it comes to how to publish across this whole spectrum, there are a lot of things to consider, but what we wanted to do today is really focus in on the four in the top left: map, vector, and feature services, and look at how best to publish those for specific scenarios and specific needs. So to jump right into the meat, we'll start by looking at dynamic map services. Those of you that have been working with maps, either professionally or casually for a number of years, might remember MapQuest as one of the original companies that did mapping over the web. This is the technology that was employed, and this is this is also the same technology that Esri first started with in its web mapping adventure, starting with ArcIMS, even before ArcGIS Server and ArcGIS Enterprise. So the idea with dynamic map services is that they leverage map images that you may remember Philip talking about a moment ago. The client application sends to the server some parameters of the image it would like to have back. What is the extent of the image? What is the size of the image? And what format should it be, which is most often either JPEG or PNG, which are two image formats that offer good compression. The server will then take that input and in effect output a bespoke image representing that specific client's request, and it will sort of pass that back in the response or host it on a web server for the client to access. And the client can then display that image much like it would display a logo or any other type of image. It's a static image in the web browser or the client application. So dynamic map services are really what power the map image layer within your portal. This is a capability that today is only supported in ArcGIS Enterprise. And traditionally, this has only been possible for user-managed data, so data stores that you register with ArcGIS Enterprise. But there have been some new changes here at 10.8. No?
Just now, here at 10.8, that was released a few weeks ago, it's actually possible to publish hosted map image layers. So this is a really interesting new development that allows you to take that hosted data and also make it available to clients through a dynamic map service.
Right. There are some key capabilities of the dynamic map service to keep in mind. So this does do server-side rendering, which means that it can produce lots of great symbology and rendering capabilities, even if the client doesn't have all of those capabilities. For example, if the client may not have WebGL, and you have sophisticated rendering rules, you can accomplish that by doing server-side rendering. It does support dynamic layers and rendering, which means that you can change not just the extent and the image size, but you can tell it which layers you want to render, even layers that weren't pre-configured with the map service to begin with, and you can pass in rendering instructions on the fly, which means that the client can determine how it wants the map to be rendered. Even though it's returning a map image, it does also expose APIs for identifying features and querying, but that's a two-part thing. The client asks for the image, and then the user clicks on the map, and then it sends another request to the server. One thing that's important to note is the dynamic map service does support some important OGC standards, such as WMS. And the map service is, it's been around for the longest, and we'll see there have been a lot of improvements in the area of feature services and vector tile services, but we continue to make improvements in the map service itself because it's such a staple for how a lot of you use the ArcGIS Enterprise. At 10.7, we added support for shared instances, which dramatically improves memory management within ArcGIS Server as you add more and more services. And we also now support dynamic feature binning for services published from ArcGIS Pro 2.4. So while the dynamic map service is in effect the oldest, it's been around for a while, it is still a fail-safe option, especially for complex data, often data that's changing very often, and is still king when it comes to working on very constrained networks where you need to render a lot of data, because you can reliably expect that image to never grow above a certain size. So moving on, we'll take a look at tiled or cached map services. This isn't actually a separate service type, but when you publish a map service, you're given the option to tile and cache it. At that point, the API to the map service does change a little bit. So instead of passing in an extent and an image size and every request producing a bespoke map image for that client, in advance of that, your data and the map is tiled in that sort of three-dimensional row level column scheme that Philip introduced earlier. And the client has to determine, when it's rendering a map, which tiles do I need in order to render this map? What level of detail, sort of scale am I at? And then what rows and columns for that particular tiling scheme will make my map complete. So it sends a bunch of get tile requests to the server, and the server then hands back a collection of images. In a lot of cases, those will be pre-cached images, although as Philip noted, those could be cached on demand. And so there are a number of benefits to this. This is what powers one of the two types, actually, that powers the tiled layer in ArcGIS in Portal. This type of service is supported in both ArcGIS Enterprise and ArcGIS Online. Might be worth noting that this session was titled and scoped for ArcGIS Enterprise users, but the content that we're talking about here we'll try to make clear where things apply to ArcGIS Enterprise and ArcGIS Online, but a lot of the principles and even the technical details are relevant to both. Tiled map services can be published on top of either data that you manage and register with ArcGIS Enterprise, or data that's managed by ArcGIS and stored in the ArcGIS data store. So important capabilities to call out. So these images are rendered server-side. They are cached using tiles. And one of the benefits of that caching and tiling is that it allows the browser to do caching as well, because these are standard images in the sense that not every image returned by the server is different. So to make that a little bit real, and we'll see this in a demo in a moment, if you pan to the west and it loads tiles, then you pan back to the right, it doesn't send another request because it actually has all of the images it needs in order to make up your map. So we often call that sort of a slippy map. It's the idea that the map doesn't appear to be re-rendering every time you move. It's because there's caching in a standard tiling scheme, it allows the experience to feel a bit smarter, and it's not fetching data that it already has. So a couple other important points about the tiled map service. You can, with this service, take data offline. So you can export a tile package that you can then take onto a mobile device out into the field and work disconnected from the server. That's something that you cannot do today with the dynamic map service. It also supports the WMTS, or Web Map Tiling Specification, OGC standard. And so tiled map services also have been around for a long time. This, in a sense, is the proven option for complex data where the data is not changing all that often. That is an important characteristic here. If the data is changing very, very frequently, updating your tiles is going to become somewhat of a burden. But if your data is not changing all that often, this can be a really nice option for really high-performing and highly scalable systems. Serving up these tiles is a very light operation on your server and a very fast operation because it doesn't actually need to fetch data. It's just handing it an image that in most cases it already has. The next service is the vector tile service, which chronologically is actually the most recent one to enter the ArcGIS platform capabilities. Vector tile service works conceptually like the tiled map service. The client requests data in a similar way. It says, I want this level or scale and these rows and columns of data, and it's going to get the tile. But what the vector tile service, what the server is responding with, is not an image, it's a set of tiles that actually contain vector data. In this particular case, the format that it's returning is something called PBF, or protocol buffer format, which is a binary format that we'll see in just a minute, which provides a really nice compression for that feature data that's returned from the server to the client. The vector tile service is also exposed through Portal as the tiled layer. This is something that's available in ArcGIS Online and ArcGIS Enterprise, but it is, in a sense, ArcGIS managed data only, meaning that you can't just publish a vector tile service and point directly at a database and expect that vector tile service to be updated automatically every time that data changes. You publish through Pro the vector tile service pointing at that data, and the vector tile service is in effect a cached version of that that's optimized for streaming vector tiles. Some of the key capabilities to keep in mind here. So here we are doing client-side rendering, which means that what's being returned from the server does not contain pre-rendered features, it's the source data, and the client then does the rendering, which means that you can provide a lot of really interesting user experiences where symbology and rendering can be changed on the fly on the client side. In today's modern devices, often provides really, really nice and crisp rendering capabilities, within your laptop or mobile device. This is cached, so these pre-tiled and cached PBFs do reside on the server, but much like with the tiled map service, they can also be cached by the browser. So as you move around, it will remember what data you had at what scales, and it will feel like a smart experience. It's not going to be requesting data that it already has in the browser or the client application.
I think an important point about the pre-creating of that vector tile cache is that it's much faster to generate that vector tile cache than it is the raster tiles that we were talking about earlier. I think I mentioned that it can take hours or even days to create a raster tile cache depending on the size. For vector tile caches, we're talking on the order of minutes to at most hours. So it's a dramatic difference, really compelling for anyone who's ever been stuck trying to create one of those much larger, slower caches to generate.
Mm-hmm. Yeah, and the size is so dramatic. I mean, you can, on just about any mobile or modern smartphone, you can store the entire nation or even the entire world as vector tiles on a device that allows you to work at virtually any scale.
Yeah.
And actually, we'll see why that's the case in just a moment. But we're talking about tens or hundreds of terabytes of data if we're looking at a tiled map service for the world at that scale.
Yep.
So I guess jumping ahead to the taking data offline, even though you could take tiled map service data offline, you had to do that for a very specific situation, a very specific region or scales, where when we look at vector tile services, we're seeing it more common that often we'll just preload a device, or often called side loading a device with the vector tile base map for the entire area, whatever that may be. It's worth noting, though, that the way that the vector tile service works, it actually adheres to a vector tile specification. As part of that specification, the idea is really to optimize it for fast streaming and for visualization, which means that the features themselves are pre-generalized and clipped to tiles. Now, the pre-generalization means that it's very fast. The clipping to the tile does have some consequences. So you can imagine you have a road segment that spans take an interstate, will span multiple tiles as it goes across geographic area. That will get clipped. So each tile will have a specific segment of that interstate feature, which makes it much more difficult to do things like identification and querying of that data client side, because the integrity of the original features is lost in the way that that's delivered. So the vector tile service today is really targeted at visualization only, and doesn't, at least today, support identify and query in most of our client applications. So to understand that just a little bit better, let's take a look at this map here. So this is a map of San Diego, and the sort of square boundary drawn on top represents the extent of the tiles that are created. And what you can see is that this looks a little bit different from the very uniform pyramid that Philip showed, and that we think of for tiled map services. And this is what we call an indexed tiling scheme. And what that means is that where there's more data, where there's higher fidelity needs for accessing dense data, we actually generate more and more tiles. So you can see we have very big tiles over the ocean where we didn't expect to see any features, and over the densest urban areas of San Diego, we see the smallest tiles. And so we're able to sort of index which areas have the most features and generate tiles at the right level of detail. And the reason that this works is that because this is vector data and not images, if you imagine doing this with images, if you zoomed into one of these less dense areas, we would be stretching an image, and you would see the pixels getting larger, and it wouldn't look good. It would look like you were stretching an image. However, because this is vector data in the tiles, not images, we're not actually stretching an image. We have the vertices for those features, and the client application can actually zoom in and render those in an appropriate looking fashion. And we call that over-zooming, which means that we basically don't need all of the levels of detail that you have in the image tiles to produce a very good looking and appropriate map for the scales that you're looking at it. So these are some of the things happening in the vector tile services. There are some compromises. We aren't able to support identify and query, but this is an extremely useful and popular option for a lot of cases, especially things like base maps.
And in fact, many, if not most, of the ArcGIS online base maps that many of you are probably using today have switched entirely to being vector tile layers. The traditional raster tile-based base maps are still available as well, but we really do encourage use of the vector tile-based versions because they're much faster for us to update, so we can get you newer data faster, and they're just that much more efficient when you're also consuming them in a client.
Mm-hmm. Yeah, and maybe we could take a quick look at that. So this is a 10.8 ArcGIS Enterprise deployment. Here I am looking at the map viewer. And so this is, you may recognize this as the topographic map. If I zoom and pan around, you can see sort of tiles updating and things are happening very quickly. Now let's see what's going on behind the scenes here. So I'm going to just open up my Chrome developer tools, and let's put this maybe over here. I'm going to zoom in to the map, and you can see a bunch of requests here. And if we look at the type of most of these, some of them are JPEG, and some of them are PBFs. So if we look at the JPEGs, let me preview these over here. I'll just scooch this over a little bit. You can see that what's coming back in JPEG is actually the topography underneath. Mm-hmm. Now this is in effect raster data.
Yep.
This is not data that exists in vector form and that we could effectively stream to the client as vector data. This is complex raster-based data. So these are pre-rendered on the server and served as a tiled map service. However, the boundaries and labels and all of the vector features sitting on top are actually served back as a vector tile service. This is sometimes what we call kind of a map sandwich. So we're drawing multiple layers as part of the base map. And I can see here some of the PBFs. If I look at the URL that's coming from a vector tile service, and you can see here there's a bunch of binary that makes no sense, except you can actually see some of these. So these are probably what's streaming back the labels. But this is that optimized binary protocol buffer format that's being used to stream vector tiles back. Now, one of the things that mentioned that's unique about vector tiles is that you can actually change symbology. And one of the things that's cool about 10.8 is we've included the vector tile style editor into the portal. So just to show that, let's switch over here to the light gray canvas base map. This is a vector tile base map, and it has a base layer and then a reference layer. And you'll notice when I'm looking at the base map, I now have this change style option, which allows me to actually change the style of the base map. And if I click this, it's going to create a new layer that's essentially a copy of the light gray canvas base map base layer that I can then style and make my own. So I'm going to save that map. And now I'm brought into the vector tile style editor, which you may have seen before. This is an application that's been available for some time on the open web, primarily supporting ArcGIS Online, although there were some mechanisms to bring custom styled vector tile maps into ArcGIS Enterprise. It's now directly integrated with the portal application. And so let me just zoom out here a little bit and we can start to see what happens. So maybe I want to change the water to something a bit more water-like. So there we go. And maybe for my land, I'm going to switch that to be something a little bit maybe more kind of manila. And if I were to zoom in, you can start to see other features showing up here. And then you can change things like roads. So maybe I'll make the roads, sort of a green color. Obviously, I'm not a cartographer. But this gives you an idea of some of the things that you can change. Now, this is just what we call the quick edit editor. You can actually switch in here and edit all of the different layers within this particular vector tile map. And so I can save and close this, and now my vector tile base map is updated. Now, sitting behind there, of course, is terabytes of data producing this multi-resolution global base map, but I can change the style of it now without having to worry about any of that. I'm just changing the way that my browser is rendering it. And if I really like this and want to make it available to other users, it's just a different item in my portal. And as many of you know, there are ways to configure the base maps. So I could even make this base map available to other users in this pick list.
Yeah, so having that vector style editor integrated directly into ArcGIS Enterprise at 10.8 is a really nice convenience.
Indeed. So last but not least is the feature service. Feature service has actually been around for some time, but it's an area where we've seen a lot of really exciting improvements over the last few releases. So the way feature services work, if you remember Philip differentiating map images from features, the client essentially sends something you can think of as like a SQL statement to the server. It's sending the bounding box or geometry of the features that it wants returned, as well as an optional where clause if it wants to apply a filter, and then it tells the server what fields it wants returned, in addition to the geometry field. And what the server responds with is features, which traditionally have been returned as JSON or JavaScript object notation, sort of a human and a machine readable format like XML that has each of the features, and with each feature it has the geometry as well as the attributes that are returned or specified in the outfields. As we'll see in a moment, this actually can now return protocol buffers, or PBF, just like vector tiles, to provide an even more optimized and compressed data packet to send back to the client. What's cool about feature services, though, is that it's not just intended to be used in that mechanism where my client says, give me all the features in my map window, and it returns it, and then the client renders it. It works in a tiled fashion, much like vector tiles and map image tiles. The client, though, instead of sending the extent of the entire map, it sends in specific tile extents for each of the tiles that it wants to render. And it uses the exact same tiling scheme, in most cases, that your vector tile or map image tiles would use. So you may think, why would you want to do that? Well, if you remember some of the benefits of tiling and then subsequently caching that Philip talked about, is by breaking these into tiles, the client can send multiple requests, and then the server can parallelize those requests. So that adds a little bit of a performance improvement. But perhaps even more importantly is because these are now standard tile requests, your browser can now cache them, which means that if you pan to the left and then you pan to the right, the browser still has that data because it knows that you have the data within this specific tile, and it doesn't have to re-request the data. So not only does it provide a better experience, it also reduces the amount of data that the client has to request, thus improving both the client performance as well as the load on the server. So there's a number of things to consider here. The feature service powers the feature layer within Portal for ArcGIS. It also powers the table item type. So if your feature service doesn't have a geometry column, it's just a standalone table in a sense, then we make it available as a table item, which behaves very similarly to a feature layer, except because it doesn't have a geometry, is not readily mappable. Feature service is supported in both ArcGIS Enterprise as well as ArcGIS Online, and can be published on top of either user-managed data that's registered with ArcGIS Enterprise, or ArcGIS managed data that you publish as a hosted service and store in the data store, the ArcGIS data store. So what makes the feature service unique? Well, it does do all of the rendering on the client side. It does also support identify and query, and increasingly we're able to do a lot of this stuff on the client. Because the client actually has the features, we can now do some of these things without going back to the server, which, as we'll see in a demo in just a moment, provides a really rich interactive experience on the client. It does support on-demand generalization. We'll touch on that in just a minute. It uses something we call quantization to reduce the amount of fidelity in the data that's returned from server to client, and thus really optimizing what's sent over the wire. And actually optimizing it in a way that the modern WebGL capabilities of most client applications can really take advantage of it. Feature service is the only of these service types that allow editing of data. So if you do want to edit your data, it does need to be exposed as a feature service. It does also allow you taking data offline as features so that you can actually use them as features in, say, a mobile device, or even edit them in a disconnected mode. It does support OGC standards like WFS. And there have been some new improvements on this, which I think maybe we'll just get into in just a moment.
Yeah.
And I would say, and this will become a little bit clear as you see the improvements, we see the feature service as almost the de facto standard for dynamic operational layers. Obviously, especially when there's editing involved, but increasingly feature services on most modern networks can tackle fairly large data sets and a lot of complex visualization. And so, yeah, I guess it's probably easier to just see what we mean. So there have been a lot of improvements in feature services. So I think the best way to show that is to look at how feature services behaved before we added some of these improvements. So I'm going to go ahead and just turn on developer tools again, and I'm going to filter this to query requests. Query requests are the type of requests that are made by feature services. So I'm looking at a map of US Census counties. And it's zoomed in here over Palm Springs, where unfortunately none of us are at the moment, but maybe we will be together next year.
Hopefully.
So I'm going to just zoom out, and I'd like for you to kind of get a feeling for how this performs. And for context, there are about 3,200 counties in the United States. Okay, so you can see it's making a bunch of queries. So far, the performance is pretty decent. It's loaded, I don't know, maybe something about 40 or 50 counties. But you can see it's already transferred over 7 megabytes from server to client. I should mention too that this county data set is the highest fidelity county data set that the US Census publishes, something about 20 megabytes as a shapefile. Now, here's where it gets rougher. So let me continue to zoom out, and you can see these are coming in rather slowly. Okay, there we go. And now let me zoom all the way out.
It's a lot of data being loaded.
That is, you can watch this counter just cranking away. You're supposed to have a joke queued up for.
Oh my goodness!
Okay, sorry. So you can see it's still going. So it's basically trying to load a lot of data because there's really no generalization that's happening here. And so there we go. It loaded about just under 34 megabytes of data, and this may be kind of hard to get a feeling for, but as I pan my map around, it feels sluggish. My browser can barely handle all the data I've just thrown at it.
A little bit jerky.
Right?
Yeah.
So now I'd like to switch over to another demo. This is using some of the new capabilities that we've added in 10.6 and 10.7. So as I zoom out, let's keep going.
So it's the same data set now.
This is the same data set.
Yep.
The exact same data set. Oh, I forgot to filter to query. There we go.
So
That
we're already
loaded,
at the full extent of the US.
Yep. That loaded pretty fast,
Yep.
right? And we're under a megabyte of actual data transferred. And I should point out that this is, I'm sorry, Philip, I haven't upgraded this one yet.
Oh.
So this is actually using, I think, 10.6.1 or maybe 10.7, and it's returning data as JSON. As we'll see in a moment, we now have the ability to return that data as PBF, which makes this even smaller.
So what really happened here was it was an order of magnitude faster to both render, and it was an order of magnitude less data that had to be transferred. Like you're saying, it's using quantization, which was one of those generalization techniques that we mentioned at the beginning. And just as I was talking now, you zoomed in and we kind of saw some very coarse-grained polygons for just a second as the new, more detailed data actually streamed back into the client. So
Yes.
there was a small artifact. We drew something really quickly before we had anything new from the client. But then very fast, we actually got the real data, and we saw the right level of detail for the scale.
We'll see that again here. I'm going to zoom in here. We'll see it's jaggedy, and then boom, it updates. And so what's happening is it is using different levels of detail, much like the other tiling schemes. And so as I zoom in to that more detailed level, it's refetching the data. But it already has some data. It's just not very high fidelity data. So as a user, I still see something, and then very quickly it's refined. And it really does provide a nice user experience.
Right. So because this is a 10.6.1, 10.7 server, and I'll work with Wit to get this upgraded, of course, but we're still seeing JSON. It's just slightly different. So if you open such a JSON response, what is it that we see? We actually see that it's not sending back real world coordinates like you might have seen in the past. It's sending back something slightly different.
Yes, it's sending back quantized coordinates. And so what that means is a few different things. So first, you'll notice that, as Philip said, we're looking at these much smaller whole numbers. We're not looking at a 10-ish digit number that represents Web Mercator in meters or decimal degrees in something like WGS84. It's just these whole numbers. Now, this is a bit misleading, but you can kind of think about this as like pixel space almost.
Screen coordinates.
Screen coordinates.
Yeah.
Because we only have a certain number of pixels to actually render the map. So if multiple real-world coordinates coincide on the same pixel, what's the point in sending that back to the client? We only need that pixel once. Now, in fact, these aren't actually pixels. There are some ways we can use to actually adjust the fidelity of this. The more accurate thing to say is that we're converting it to a virtual space that's more optimized for whatever fidelity I want to look at the data at.
Yep.
So that's the first thing, and that makes a big difference. So for all of these, we've just cut down like at least a third of the size. We then, you'll notice that only the first one is absolute. The next ones are relative. So instead of storing each much smaller coordinate individually, we're actually just storing it as the pen moves. So the first coordinate gets drawn here, and then we go up one, left one, up one, right one, and that provides an even more optimized version of how we store this data. And then the other thing that is maybe implied here is that we're actually removing vertices that we don't need after we do this mapping. So it ends up being a much smaller thing. And one last point on all of this that I think is important to note is because we now have all of this data on the client, we can do some really powerful things that we've never been able to do. So this is a map that allows me to do a sort of a bit of a spatial query and find out the number of homicides within the Chicago area. So I click on the map and it does that identify. That's great. I've always been able to do that. But now I can actually drag this around and you can see that it's doing all of these queries in real time. It's not actually going back to the server anymore. It's querying the data that exists in the browser. And so one of the powers of feature services is that we have the original features, that have been, sort of optimized for my view, stored on the client that I can then use to do things like this. And this type of capability is exposed through the JavaScript API.
Yep. Awesome.
So we're going to move along pretty quickly. Here, there's been a lot of performance benefits, but actually, Philip, maybe you want to talk to this.
Sure. So one of the things to understand is that a lot of these performance benefits that Whit just showed in a very tangible fashion actually come along more or less for free, if you will, once certain prerequisites are in place. So we mentioned that at ArcGIS Enterprise 10.6.1 was when we first introduced quantization. And then at 10.7.1, we introduced this new performance improvement where we're not sending JSON, but we're sending this optimized binary format instead. So that's a really, really cool thing. What you need to understand is that it's both the server side that needs to be updated to one of these newer versions if you aren't there already, as well as your client-side application. If you're building your own web applications using the ArcGIS API for JavaScript, you need to be at a certain version. So JavaScript API 3.24 or 3.24 or 4.7 and higher supports this. You get the benefit of the faster processing on the server, as well as much smaller payloads are being transferred over the network. That was the difference between that 40 plus megabytes worth of data versus 400 kilobytes, truly an order of magnitude difference. You get faster rendering in the client side as well. This is particularly noticeable in web clients. If you're using the right version of the JavaScript API, this is completely seamless, and it just takes advantage of and recognizes that the server has this new capability and makes use of it. This is also used by ArcGIS Pro when connecting to a feature service that you've published using one of these newer versions of ArcGIS Enterprise. And of course, the ArcGIS Enterprise portal itself has a number of applications built in, such as the map viewer that we were just looking at, and those have been enhanced to inherently make use of this feature. Those additional performance improvements beginning at 10.7 apply to services published from ArcGIS Pro specifically because of that binary transport format that we introduced, PBF, that replaces JSON. So that's a lot of information. This is intentionally a very busy slide. There's a lot of text. We also tried to summarize it here in just a couple of tables to kind of give an overview of what's there across versions and the different types of map and feature services that you can support. Ultimately, this is a fairly simple table that says you have quantization supported for any type of map and feature service if you are using 10.6.1 or higher. PBF support is slightly more nuanced. We've added support for returning PBF under the hood to map and feature services that you've published from ArcGIS Pro, and that was supported beginning at 10.7. Hosted feature layers, regardless of how you published them, also now support returning PBF beginning at 10.8, which was just released. Ultimately, you don't have to do anything yourself to take advantage of this. The clients will figure this out and recognize what's available, but if you're truly trying to get every single last ounce of performance out of the system, then it's important to understand what came in at what versions. All right. We'll go a little bit fast through the last pieces here and just talk about the difference between a feature service, the actual web service that you're publishing from your server itself, and the client-side concept of a feature layer. If you remember back to those tiers that we introduced at the beginning, the feature layer is really something that sits one tier higher than the feature service itself. And something that we very much think is worth pointing out is this distinction between using a feature layer at the client side and the option or the potential to actually point to an individual layer within a map service. In other words, you don't have to point to a true feature service under the hood when you're using a feature layer. We find that this can be a little bit counterintuitive, and the naming doesn't necessarily help with this understanding. But pointing to a layer within a dynamic map service from a feature layer really gives you a lot of these same benefits. It's more or less the equivalent of a read-only feature layer. It simply doesn't support editing and offline synchronization. It does give you all of the other benefits. So you don't necessarily need to publish a feature service, in other words, enabling that feature access capability of your map service in order to make use of this rich client-side rendering if you don't want to enable some of these other more powerful features like editing and offline sync.
So if you, for example, have data in a file geodatabase that you want to expose as a feature layer, you can do that because you can't publish that as a feature service. You can continue to use that as a map service, but then register the individual layers in your portal and consume them as we just showed.
Exactly. So map services can be published from quite a lot of different things, including file geodatabases and other locations that don't necessarily support publishing a feature service. But that doesn't mean you're cut off from this, quite the opposite. You can still do quite a lot. We'll jump a little bit further ahead now to trying to put all of these concepts together. Whit, maybe you can bring all of this together.
Sure. So in the beginning, we used a couple different examples. So we thought we would just revisit some similar examples to see how we would use these different publication strategies to bring things together. So in this first example, we have an imagery-based map that's on which we're rendering weather data. So this might be something that, for example, the National Weather Service is producing. And the use case here is really to be able to see this over the web across a variety of devices in connected use. So typically the way that we would see this being done is for the imagery-based map, which is raster data. We would serve that as a map service, tiled. So we would serve tiled map images through a map service that renders that, that's pre-rendered all of those, the satellite imagery as tiles, as JPEGs that are then served back up in a very quick and scalable way. And then for the more dynamic weather data that's being drawn on top, because that's a fairly complex set of data that's not as easily transferred as features over to the client, that we also want to expose to a wide variety of users, we're going to serve that as a dynamic map service on top. And you can sort of see those two thumbnails on the right. Imagine how they overlay to produce the map on the left. The second example is really more of a utility example. So we might have a street map on top of which we're rendering more complex utility data. And in this specific case, my target audience is users in the field who may be working offline. So to support this type of use, we would probably be looking at getting that street map onto the device as a vector tile base map, probably stored in a local tile cache on the device, maybe even side-loaded when the device is provisioned. And then on top of that, we'd be rendering the utility data as features that we would be getting from a feature service. And we'd be able to leverage the offline sync capability of the feature service to bring that data down to the client. And if this client happens to be editing that data, it could edit in a disconnected fashion and then sync that back to the server. So two different sets of services here brought together to support a completely different use case. And so you can see how there's all of these different pros and cons of these different service types. Doesn't mean one's better than the other. It really depends on what you're trying to accomplish with for your user with your applications. So as you think about how to make the decisions for your specific scenarios, we'd like to remind you to keep some of these things in mind. So a lot of this will be driven by business as well as IT or sort of technical requirements. So you want to be thinking about the use case, sort of the user tolerance for the amount of data, the speed of the application, the degree to which they have to have connectivity, the type of data and how frequently it's updated, the bandwidth of the network and how reliable the network is. The type of device your clients are using. Can you assume that everybody has a modern laptop with a GPU-enabled graphics card, or not? Or are you working against mobile devices, for example? And then the speed of the compute that you have on the server. And in terms of the different knobs that you can turn and the capabilities that you can bring to bear to meet that, some of the key things to be thinking about would be the type of service that you select to publish various layers as, leveraging tiles and caching to the degree that you can, and then using generalization techniques. And if you can't use on-the-fly generalization, then you can always look at pre-generalizing. And then to make the most use of your server resources, do the best that you can to leverage the capabilities of that portal information model. What I mean by that is web maps and web layers, so that if you have the same data providing the same functionality, but maybe one's rendered a little bit differently or one's got a filter on it, there's lots of capabilities in the portal. You can apply filters, you can create things like views to render that more efficiently. And then just remember this, we want to focus on the business, start with the end consumer, and then work from the bottom up with the data that you have, and try to stay agile and align with the state of the technology today, because this is changing very quickly. And so with that, maybe Philip, a couple key takeaways?
Yeah. So I think the key takeaways we're really going for is remember to put together that publication strategy and make sure that your strategy is appropriate for the consumers that you're trying to meet the demands of, and making sure that the performance, scalability, reliability, all those things are kept in mind as you're putting together your strategies. Take that business first approach. Don't necessarily take this technology and try to shoehorn it into a certain thing. Look at what are the requirements of the business and then build your services, your strategy, your approach accordingly. ArcGIS Pro really is that primary publishing application these days. That's where a lot of these newer functionalities are coming from. There's rapid improvements between ArcGIS Pro and the corresponding versions of ArcGIS Enterprise. And then, like Whit mentioned here at the beginning, we didn't get to touch on it a whole lot, but the geoinformation model does give you quite a lot of options for doing configuration at higher tiers in the system, which can often be very efficient. There's a trend towards feature services, or rather feature layers and vector tiles. If you haven't already started making use of these, or if you have the impression that feature layers are not as efficient as dynamic map services, we very much encourage you to revisit that. Those enhancements that we've made over the last several years and several releases are really game changers in many ways. And with that in mind, this continues to evolve, right? This is not the end-all be-all, so if you're watching this video a year or two from now, definitely do your homework and see what's changed since we recorded this. And with that, thank you so much for tuning in. We appreciate it. We hope to see all of you next year in Palm Springs for the Developer Summit 2021.
Great, thanks.